And now we go to another part of South America, which is not really part of the continent anymore, but some very biodiverse but remote islands in the middle of the Pacific. So we go to Jonathan Green, who is the leader of the whale shark project in the Galapagos Islands. Jonathan, are you ready?
Yes, yep, I'm here. Can you,
right.
You can't see me yet. So let me see if we can start my video. My video will not start. It says host is not allowing my video. Can you hear me? Okay, start my video.
Yes, because, all right, yeah.
Okay, well, thank you very much for the invitation to the Wilderness Week, and greetings to everybody out there, wilderness and nature lovers, fellow scientists, colleagues, friends around the world. I'd like to talk a little bit today, as John has mentioned, about the Galapagos, and very specifically the Galapagos Whale Shark Project. So if the technology is permitting, I'm going to see if I can start a quick presentation. So very briefly, as you've already mentioned, can you see my video live now? How is the technology? Can you see my presentation?
At the moment, we cannot see it yet, Jonathan.
Okay, so let me go down to share screen. Okay. How's that? Can you see me now?
Yep, perfect. We can see you.
Okay, fantastic. Well, again, thank you very much for the invitation. I'd like to talk quite specifically about the Galapagos Whale Shark Project. Just very briefly, my involvement in this project began quite a number of years ago. I trained originally as an earth scientist. I'm a geologist, geographer, physical geographer, but with a big interest in the oceans, and I've been diving for many years. And in 1988, I was fortunate enough to get the opportunity to go to the Galapagos Islands and train together with the Galapagos National Park Service to become a naturalist and dive master within the Galapagos National Park and the later Marine Reserve. So it was one of those opportunities that I think everybody really dreams of. And certainly, I remember as a child growing up, the fascination with Jacques Cousteau and the underwater world. And I can still hear his voice as he would talk about, and we would dive and explore into the caves, and we never knew if we were going to come back alive, and things like that. So I think that was what really got me interested as a child in the underwater world. As a geologist and also growing up, I think like anyone of that age, I was fascinated by dinosaurs. And so it was when I was in the Galapagos that I got presented with a very, very unique opportunity. And I moved more from the physical scientists into the underwater world because I came face to face with a whale shark. I frequently get the question, is it a whale or is it a shark? Well, the whale shark has the name whale because it's a filter feeder and it's of an enormous size. It's probably the largest shark and the largest fish ever to exist on our planet. So even bigger than Megalodon, almost certainly, but it is, of course, a gentle giant and a filter feeder. And you can see in this photograph here, the size of a diver. That's one of my colleagues. He's 6 feet, almost 2 meters in length, and you can see the size of the whale shark below him. So it was this encounter back in, I think, 1989 or 1990 that triggered me to start asking a series of questions about whale sharks in particular, and about the role of the Galapagos in the life cycle and possibly the reproductive cycle of whale sharks. Now, I think everybody who's probably listening today is absolutely aware of the Galapagos, its significance in the natural history, the history of the Galapagos Islands with Charles Darwin, the information that it gave him and the trigger it became for his proposing the the theory of evolution and natural selection. And I think everybody would immediately mention giant tortoises and a volcanic landscape and all of the unique animals that live there. But very few people perhaps are aware of the underwater world. Now, Galapagos is not just unique flora and fauna. A lot of the animals have also developed techniques or strategies for survival as well. This is one of the famous Darwin finches that has become the world's only vampire finch. And you can see here feeding quite happily on the blood of a Nazca booby. There was probably a symbiosis beforehand which existed whereby the finches were removing ticks or parasites from the boobies. And so the boobies accept this behavior because they think they're getting a cleaning. But what the finches are now doing is they're pulling out the developing primary feathers in the wing. And this acts just like a pipette, and the blood begins to flow. And during the particularly dry periods like La Nina, when it's not raining and there isn't the fine mist that provides the fresh water and the liquid, which is vital for the survival of so many species, the finches have found a way to survive simply by sucking the blood of the boobies. And as I say, they're allowed to do this because the boobies still believe they're getting a cleaning. So in many ways, Galapagos is completely unique because of the physical development or evolution of the species, but also because of the behavioral ones. Now, Galapagos is totally unique, and you've heard this over and over again. But why is that? It's the geographical position. It straddles the equator. If you look at the islands, they're way offshore, about 600 miles or 1,000 kilometers offshore of Ecuador, the continental mass, which is closest on the mainland. But because of their position, they're affected both by tropical marine currents, which come from the north. So we've got the Panama or the El Nino current, which comes down from the north. And that meets very, very cold currents, such as the Humboldt current and the Cromwell currents as well, which probably originate in Antarctica. And because of the meeting of these two huge marine currents and climatic situations on the equator, you get an absolutely massive explosion of life, all the way from unicellular life up to, well, the very, very top of the food chain, of course. So the position of the Galapagos Islands is totally unique. If you walk all the way around the circumference of 0 degrees, the equator, on the planet, you won't find anywhere else which is like the Galapagos. It simply does not exist. So that's why the Galapagos Islands are so important to the diversity, the biological diversity and abundance of species and wildlife in this particular area. In fact, we could call it the cradle of life of the entire tropical Eastern Pacific. Again, it's quite unique because you've got tropical species like parrotfish swimming around, but at the same time, a penguin, which you would associate, of course, with the subpolar or polar regions like the South and the Antarctic, are also swimming by. So, as I say, Galapagos is completely unique. Some of the wildlife there have developed to an extent that birds, for example, now breeding on the ground, have lost their ability to fly. The absence of land predators, so big cats, foxes, bears, dogs, and so on, has meant that wildlife can simply nest on the ground and they're safe. And that is why introduced species like cats and dogs or rats or wild pigs are so devastating to these isolated island ecosystems, because the wildlife simply doesn't have any defenses there. And then we have other species like this, which only exist in the Galapagos, again, completely endemic, the world's only marine lizard, or the marine iguana. But very few people are aware of the importance of the oceans and what is below the surface. And I think this is very typical of our oceans worldwide. We have a better idea of what's going on the surface of the moon. And in fact, the surface of the moon is geologically better mapped than the ocean floor below us. So many species are out of sight and out of mind. And I think we don't really understand fully the effect that humans are having on the wildlife, and especially the mega fauna. So these big animals like the sharks, for example, the rays, the turtles, marine mammals, and so on and so forth. So when I came face to face with a whale shark in more or less 1990, I began to ask a series of questions to my colleagues, my peers, and to any scientists basically that were willing to talk to me. And the question was, well, what are the whale sharks doing in Galapagos? Where is it that they're breeding? Because nobody seemed to be able to answer that question. Where are they feeding? What are they feeding on? Where do they give birth? Because Like some of the other sharks, they're ovoviviparous. So ovo with eggs, vivi live, and paris giving birth. So the eggs are internally incubated and they give birth to live young. So my question was, where are the young birthing, and where do they live for their formative years of life, their first years of life? And nobody seemed to be able to answer these questions. And I think that's what really triggered the interest at that point. And so I got together with a group of fellow dive masters and said, this would be a great study subject. Why don't we look at their behavior? Why don't we take simple observations? So we did that for a number of years, but very quickly became aware of the fact that we were literally just scraping the tip of the iceberg. And that in order to really discover the role of Galapagos in the life or the reproductive cycle of the whale shark, we needed to look much, much more in depth, and we needed to use the technology that was available at the time. So in 2005, together with Dr. Alex Hearn, who was working at the time with the Darwin station, we put together a proposal to create a more formal study. First of all, we wanted to determine the sex of the individuals that we were seeing. Then we wanted to look at the DNA for population dynamics, but also to look at how closely they were related to other populations around the world. The whale shark is a single species, Rhynchodontipus, and that single species is the one that is found in the Indian Ocean, the Atlantic Ocean, and of course the Pacific Ocean. So we wanted to look more closely at the DNA and what information we could gather from that as to how closely related each one of the populations from around the different oceans was. And then photo identification. The pattern of white spots on a whale shark is unique, just like the human fingerprint. So if you get a photograph of a specific area and you capture it, you recapture it in a different place or subsequently in the same area years later, then you can actually identify that individual, and that gives you an idea of how they're moving around the world. And then, of course, satellite tagging, using different types of satellites. The spot tag, which is like a GPS and gives you the position when it reaches the surface. A PAT tag, which stands for pop-up archival tag, and gives you basic dive profiles. So how deep are they diving? How long are they staying down? So time at depth. And then more recently developed splash tags, which give you both the GPS, so the surface information, and the dive profile. And that is very, very important to understand how they're diving, where they're diving, and what is it that provokes their diving. Because it might just be because of filter feeding, it might be because of mating, it might be because they're giving birth at depth. So there's a whole series of factors that you can discover by using satellite technology. And then we wanted to look at blood chemistry, because blood chemistry tells you all about the basic health. The first thing that happens when you go to the doctor and you say, I don't feel particularly well, they're going to want to take samples, and usually they're after blood samples, and that gives indicators as to baseline health. So that was very, very important to understand their basic health, but also it gives you an insight into subjects or facets of health, like, for example, hormones, and hormones might tell you more about the reproductive status of the particular animal. Because we were convinced that a lot of the large females that were coming to Galapagos were possibly pregnant, we also wanted to try out ultrasound. And we were fortunate to be the first group ever to carry out both blood chemistry or blood draw and ultrasound in a free swimming environment anywhere in the world. So this has been done in aquariums, in captive surroundings, and it's been done when animals have unfortunately become entangled or captured in nets with the fishing industry. So, but the very first time that this was done in a free swimming environment was in the Galapagos, and that, of course, was quite an interesting experience. And we're also trying to develop tags that will indicate how deep they're diving, because currently the satellite tags that we're using are rated down to a depth of about 2,000 meters. That's 2 kilometers. And we know that they dive past that limit because almost certainly our tags are getting crushed. And at that point, we're losing sight of the animal and what they're doing. Now, one of the questions I frequently get is, why are you studying whale sharks? Well, up until about 1990, they were being taken by fisheries around the world that were sustainable fisheries. So you've got a lot of local coastal fishermen that were pulling them out. But unfortunately, in 1990, they became a goal of the industrial fisheries. And of course, with other shark species disappearing around the oceans, rapidly they were being taken because of the value of their fins. So I apologize for the brutality the horrific nature of this photograph, but this is the reality of them, and this is why we need to understand their reproductive cycle, to understand the role of these oceanic areas in the and what importance they play for the whale sharks, if we're going to be able to afford them protection in the future. And this is why, unfortunately, in 2016, their status was upgraded or downgraded, as I would see it, to endangered from vulnerable or threatened. So unfortunately, they're now being targeted, as I say, for their oil, for their fins, for the shark fin soup market, and of course for squalene oil. So if you do go out and buy products, especially in pharmacies, and these are pharmacies all the way around the world, we're not just talking about the Asian markets, we're talking about the US market, the European market, the UK market. Please check if you buy things like glucosamine, make sure that they don't contain squalene oil, because that comes directly from sharks and rays. And if you're buying products with squalene oil, you are helping or adding to this problem. So anyway, the work itself and the project, in 2010, we started the formal science, if you like that. And here we have one of our scientists taking a blood sample from the pelvic fin. You can imagine as an animal, which is somewhere in the region of 20 to 30 tons, swimming by. It's about the size of a small single-decker school bus, if you like, and they reach lengths. In Galapagos, the average is between about 11 to 13 meters, but we've also seen animals of about 15 meters long. That's 50 feet long in length in total. So you can imagine how interesting it is to actually do this science, because it hadn't been done before. And so we had to develop the techniques. And this is one of our scientists from the Okinawa Churishima Research Center in Japan, who have one of the only independent ultrasound units that can be used underwater. This weighs a total of 17 kilos, which is about 40 pounds. So as you can see, he's not wearing a weight belt. But all of these techniques we had to practice and perfect underwater. And you can see this huge abdomen of this female whale shark. And surprisingly, the first piece of data that we came up with and discovered was that over 99% of all whale sharks visiting the Galapagos are actually females, adult females, and they have these massive distended bellies. And we believe that they may well be pregnant traveling through the Galapagos, and Galapagos may play an important role in the birthing. So here you can see the very first images of egg follicles inside the ovaries. This was a very exciting moment for us, of course, to be able to determine this. And what we do hope is that in the future, with more work, that we'll be able to actually see whether they're carrying the unborn fetuses. For the satellite tagging, the satellite tags themselves are tiny, and this is the equivalent of someone putting a tiny little ear stud, for example, or earring in their ear. The whale sharks don't actually feel it, so this is a splash tag that we're putting on here. They're tiny little units that barely weigh anything. They have a wet-dry sensor, so every time the animal comes to the surface, it sends up information to the satellite, the Argos satellite platform, and we receive that information then, and we can download it. And as I say, it gives us information not only about where they are on the surface, but also what they're doing underwater. And you can see here the position of the tag on the top of the dorsal fin. So it works like a little closed peg or a closed pin under pressure. It simply clips on the fin itself, and after a period of time, it degrades and actually falls off. But hopefully we'll get several months, possibly over a year of data before the actual tag comes off. This is a short video. I apologize that it seems to be jumping for some reason, but I would just like to share with you very quickly this video which shows the technique. Here we are, just putting a tag on the animal. You can see the size of the animal as it swims by. It's very huge. They don't even feel it when you put that little clip on the dorsal fin. And in fact, the animals frequently are so curious as to what the divers might be doing. You can see a colleague who's also taking photographs for photo ID, that they turn around in full circle and they come back to get a better view of the divers. So this is not an invasive technique. There's no stress put on these animals whatsoever. We often get that question. And you can see here that the whale shark simply turns around to come and visit us. But here is the information that we start to get. The satellite tracks themselves, which give us the data, the information to better understand how they're moving on a local basis, how they're moving on a regional basis, how they might be moving around the globe. And with that information, we can then take that data and go to organizations, government institutions, and say, we need to protect these areas because the animals are using this particular area as a swimway. And this is the kind of data that we can use to then create marine protected areas. Without baseline information, without baseline data, you cannot come up with legislation to extend or create marine protected areas. You must have very, very sound and detailed information to convince governments to do that. And our information, fortunately, has been used to support the creation of an international swimway between, for example, Costa Rica, Cocos Island, and the Galapagos. The information also shows how they're traveling down to adjacent countries, so from the Galapagos down to the shelf break of Peru. And this kind of data is what we need absolutely to better understand how they're moving around the oceans and how we can protect them. This is the case, unfortunately, or this is the track of an animal called Hope that we tagged back in September of 2009, and we were tracking her until May the 22nd of 2020, when her signal unfortunately disappeared. We don't know the reasons for her disappearance. She was about 2,000 kilometers to the west of the Galapagos, but the light spots that you can see there indicate fishing activity. And when she disappeared in an area of very, very intense fishing. We don't know, but we do suspect that she was captured, possibly by one of the netting boats that was in this area. And her, what happened to her could be what is happening to many whale sharks, especially the juveniles. Hope was a juvenile whale shark, probably between 7 and 8 meters in length, and that would certainly be an easy prey for these big netting vessels that are plying the international waters. And unfortunately, this kind of activity of the international fishing fleets is completely unregulated and uncontrolled. So much of this is going on unobserved, and there's very little we can do at this moment to stop that. So we do need much, much heavier regulations, better regulations to protect wildlife, because they don't just live in the marine parks. They're not just going to stay in the marine protected areas. They swim out into international waters, and that, of course, is when they're prey to any vessel which may be fishing in those areas. So it's massively important that we gather this kind of data to then be able to possibly create better protection for them in the future if they have a chance of survival. And this is the example of Coco, an animal that swam directly from Darwin Island, pretty much up the Carnegie Ridge to Cocos Islands. And again, this is the kind of information which is so important to say we need to protect this area because obviously it is a swimway. So what about the future of whale sharks? Well, I think in the future, if we can gather this data, we can create awareness, and platforms like this one, this Wilderness Week, is so important to get this information out to the public because, as I say, most of what is going on in our oceans is simply out of sight and out of mind. So we need baseline data, we need education, conservation, legislation, and this will create larger marine protected areas. And then hopefully we can give this species and so many other species a decent future in terms of conservation, so that our children's children can see sites like this. And this is what the Galapagos is like today. If you go to the Galapagos, you can see hundreds and hundreds of sharks swimming by. And this is what our oceans were like before humans really began to affect them. So hopefully the future of our oceans will be with these megafauna, and these are the sites that we'll continue to see, and our wildernesses will remain intact. Thank you.
Thank you very much, Jonathan. Very, very nice pictures and a great inspiring story. The whale shark is actually still high on my to-see list. I still haven't seen it. So I hope to, at some point in my life, also make it down to the Galapagos and see it with my own eyes.
It is an extraordinary place, and one of the few places where you really come into contact with a primordial Earth. You know, this is what Earth looked like, or the oceans looked like thousands or even millions of years ago, because we're looking at these species that have been around for millions of years. It's a very, very unique experience.
Would you say, sorry, go ahead, Max.
Yeah, sorry about that, Nick. How do you see this new push to have more marine protected areas? I hear the number of 10% of the ocean should become a marine protected area. On land-based, we already have within the IUCN a movement of 50-50, which means 50% used by humans, 50% to be left in a natural state. which is a really revolutionary concept when you think about it. But how do you view this? Is this just hot talk, or do you actually see there an opportunity, and what needs to be done? Because, you know, we have these so-called wild coast, which is the linkage between a marine protected area and a land-based protected area, because we found out that one of the least researched is exactly that interface between Earth, the landscape base, the you know, and the water. We look at the water, we look at the land, but we don't really look at that interface. And so how do you see that push for more
Well,
protected
I mean,
areas?
I think right now there is an awareness. Certain things have happened over the last maybe 5 years, I would say, possibly 10, but certainly the last 3 to 5 years have been critical in the change in awareness of the general public, how important oceans are to sustaining life on Earth. And I think possibly the COVID pandemic has shown that what is happening on one side of the planet has repercussions on the other side of the planet. We're no longer a bunch of little nations that can live independent of others. What we do, as I say, in one part of the world is going to affect us as a global nation. So the importance of the oceans is now becoming very, very clear as the cradle of life, the very, very source of all life on Earth. So I think it's absolutely dire if we as the human race are to have a future, a healthy future on this planet, we take a serious look at what we're doing to our oceans. What we're doing right now with the international fishing fleets is not sustainable. We are extinguishing life in the oceans. And it's a simple equation. Life in the oceans disappears, life on Earth will disappear too. And that includes humans. But in the meantime, we're going to suffer horribly with many other things, not just a simple pandemic that we're suffering right now, because this is not even a yellow card. This is just the referee blowing the whistle right now to stop the play. So this is a simple warning of what we're doing to the oceans is having an effect on the Earth. We need to create more protected areas. Right now, the resistance is coming mostly from the fishing sector. But what has been proven over and over again over the last 3 decades, since marine protected areas really began, is that there's a massive spillover effect, a domino or a ripple effect that actually increases commercial fishing volume by protecting and laying or putting aside certain areas as non-fishing or no-take zones. So it actually benefits the commercial fishing sector as well. But there's huge resistance from them because what they fear is that they'll no longer have access to these areas. And that's not the case. What you're looking at is a long-term management of these areas, which says, okay, let's continue to look at stocks. And the moment that stocks show any kind of effect, we need to change our management policies. We're not saying don't fish. We're saying we need to adjust how, where, and when we're fishing. So it's absolutely paramount that the studies between those areas, the coastal areas and areas like Galapagos, which, as I mentioned earlier on, are probably the cradle of all life in the Eastern Pacific, are better understood. Because the dynamics between these areas, the Earth to the ocean, are all so closely interconnected that it would be so easy to upset that equilibrium, that balance. And as we know, unfortunately, with a lot of these resources, once they've been driven to the point of extinction or biological extinction, recuperation could be hundreds of years, which of course is too late for our generation and the next 2 or 3 generations. So I think it's absolutely dire that we increase the...
Before we switch over to Tobias.
Yes.
Give you an advice. Don't even think about these marine protected areas about management. We learned the hard lesson on land-based protected areas, and every time humans try to manage something, excuse my verbatim, they F-U-C-K it up.
Yeah.
That's why the wilderness concept has emerged, where literally there is no management in the core zone. There is no hunting, there is no fishing, there is no berry collection. If it burns, it burns. It's the natural dynamic process. But it's also a big step for us as scientists because of climate change. We are again inclined to intervene. And I think you have made a good point in your presentation. sometimes nature can take care of itself, and even if it's climate change, it will cope with it one way or to another. Yes, some species may disappear, but nature has survived 5 billion years of evolution. We are the ones who really will suffer, not nature. I mean, nature will survive whatever hell we do. And
Some
new
species.
species will appear, others will disappear, but it's our life that is at stake.
Oh
Thank
yeah,
you
absolutely.
for the good presentation.
My pleasure. Thank you very much for the invitation. Thank
We
you.
stay in touch.